Saxon Math Course 2. We are in lesson 40 today, and we're going to be talking about two major things. Number one is this idea of some of measures of a triangle. Okay, we're going to look at a triangle, and then we're going to look at angle pairs. To start with, what I'd like to do is I'd like to go to page 286 in your textbook under the new concept and look at the top of the page there. And I want to show you a couple of things that are really important. All right. First of all, I want to focus in on this area right down here. You'll notice that I have a square, and then in the bottom of this intersection, there's kind of a representation of a square. And here I've blown it up over 100% so you can see it. So here was the corner, and then there's this indicator box. That means that it's a 90-degree angle guaranteed. Okay, so if this is square, that means every single other one of these angles is also square. Okay, so if we have a triangle, notice I've bisected this box, and what I'm going to do is I'm going to draw as close as I possibly can half of the box. Okay, we know that this is 90 degrees, so I'm going to say 90 plus, and then half of 90 of both of those, because we've cut it in half, is 45 degrees. This one is 45, and this one is 45, plus 45 equals 180 degrees. Now here's something really important for the rest of your math career, is that the interior angles of a triangle always equal 180 degrees. All right, so any triangle inside angles always equal 180 degrees. Okay, so literally we have 180 degrees on this side, and we have 180 degrees on this side. So inside this triangle is also, the interior angles are 180 degrees. So with that understood, we know that the measure of an angle depends on what the corners are. Okay, and so today we're going to be working on that example. In your lesson on page 286 and the top of page 287, they have you do a little exercise, which is kind of fun, with paper, a ruler, a straight edge, a protractor, and scissors. I'm not going to have you do it right now, but if you want to, okay, you can work on this, and it's quite kind of amazing how angles actually work out. And so if you want to have some fun, if you're in origami and folding paper and that kind of stuff, this is your gig. I'm going to skip ahead to example 1, and if you notice example 1, there is a triangle that is drawn here, and there's only one indicator here that we just talked about. There is a 30-degree angle, and we know that this one is equal to 90 degrees. So I just said that the triangle, okay, any triangle, interior triangle, has a total of 180 degrees in it. Well, I found out that there was 90 degrees and 30 degrees plus something else. I don't know what this one up here is because it doesn't give it to me. So I do know, and let's put X, okay, because I don't know what it is. I do know that the total is 180. So 90, make it better 90. There we go. Plus 130 equals 120 degrees. Plus X equals 180 degrees. So how can I find out what X is? If I subtract 120 degrees from both sides, what's left over here? It's 60 degrees. So I know that this angle right up here equals 60 degrees. So I can find out the unknown angle. So angle A equals 60 degrees. Well, what does B equal? B equals 30 degrees, and so on. Pretty simple how to do that. All right, let's go to the next concept, the next idea, and that's going to be found on page 288. And in page 288, you will notice that there's this kind of weird looking angle thing, and we will call that eventually an angle or a line that's cut with another line. We will call that a transversal, but that's for a little bit higher math. You don't need to worry about that right now. Let's look at these angles, okay? First of all, you have what's called adjacent angles, okay? We're going to start with this term right here. Adjacent, the term that you can put that might make a little bit more sense is next to, okay? So number 1 and number 2 are adjacent angles. Number 1 and number 4 are adjacent angles. Number 2 and 4 are not adjacent. They are what we would call opposite angles because they cross over. So adjacent means that they have to be on the same plane. And you see a plane right here. So 2 and 3, 3 and 2, 1 and 4, 4 and 1, 3 and 4, 4 and 1, or 2 and 1 and 1 and 2. Okay? That is what an adjacent angle is. All right, let's talk about supplementary angles. Okay? Supplementary means that, and I'm going to draw a big red arc here from 1 to 2. What is the arc from that? If it's a straight line and this is a right triangle, that means 90 degrees plus 90 degrees. So supplementary angle means 180 degrees. That means angle 1 plus angle 2 is equal to 180. And I mentioned that 90 plus 90 does equal 180. So now I'm going to jump down here and quickly talk about, instead of supplementary, we're going to talk about complementary. Both of these are kind of related. So if supplementary is 180, complementary is only going to be equal to 90 degrees, which means this, and I'm going to do it in blue. A complementary angle, I'm going to use angle 1, is from here to here only. Supplementary goes all the way. Complementary is only from this line and this line, which you can see, again, is only 90 degrees. So supplementary is both. Complementary only gets you 90 degrees. All right, there's 3 of the terms. What is a vertical angle? Vertical angle is simply what vertices happens. Okay, so a vertical angle is something that is going up or down. So this would be, this line up here is horizontal. This one going this direction would be vertical. So our vertical angle would be 3 and 1 because they're going this direction. All right, so angle 3 and angle 1 would be my vertical angles. Because I drew this and it is kind of shaping up in this direction, you could argue that 2 and 4 are also vertical angles. I should have drawn it so that it was more of a straight with that kind of look, so that you could definitely tell that this was straight horizontal and this was vertical, if that makes sense. I think it does. All right. So let's look at a couple of other examples that they give us. All right. And in your lesson, you're going to see something that looks like this. Excuse me. Where the angle is, we're looking for several different angles. Okay. And they give us 50 degrees up here, and they tell us that this is a right triangle, which means it's 90 degrees, and we don't know what that one is. In fact, they label that X, and then they label this Y and this Z, and they tell us to find X, Y, and Z. All right, not as hard as you think. First of all, let's start with this triangle and come up with angle X. And you'll notice something. Angle X right here is going to be the exact same as this angle. So x and z are going to be the same number. So I'm going to just put red marks there to indicate that. So how do you find what angle x is? Well, 50 and 90, so we're going to say 50 plus 90 plus, we don't know what angle x is, equals 180, because we know the interior equals 180 degrees, and each of those are actual degrees. All right, so 50 plus 90 is 140 degrees, plus x equals 180 degrees. Let's get x by itself. So we'll subtract 140 here, subtract 140 here. We notice that these cancel off. X equals 40 degrees. So x is equal to 40 degrees, which means z is also equal to 40 degrees. All right, so if z is 40 and x is 40, I want you to think about this, and I'm going to go to green here. You might have a hard time seeing it, but this right here is a straight line, is it not? That's a straight line. So if this is 40 degrees down here on this section, if I make this arc all the way here of 180 degrees, that means I can say 180 degrees minus 40 is going to give me y. That would be 140 degrees. So that is what y equals. Y is 140 degrees. All right. So that also means that the opposite of y, if this is 140, that means this is also 140 degrees, because opposite angles are always the same. Okay, so you'll notice that this angle and this angle are the same, and this angle and this angle are the same. All right. Okay. Little bit maybe congested there, but I think it's easy to see. All right. So let's look at one more example. We're going to look at example 3, and it says that there's a parallelogram. Well, what's a parallelogram? Well, if you remember, we have two angles here, and then this one going this direction. And you'll notice that this parallelogram is labeled A, B, C, and D. And then you'll also notice that this parallelogram is cut right in half. And they give us two angles. This is 60 degrees, and this is a smaller one at 40 degrees. Okay? So the question says segment BD divides the parallelogram into two congruent triangles. Angle CBD measures 40 degrees. Which other angle measures 40 degrees? So it was angle CBD. Well, what is CBD? Well, C starts here, it goes to B, and then goes to D. So if you made that angle, it would be this, and that is our 40-degree angle. So it says, what other angle here equals 40 degrees? So if angle CBD equals 40 degrees, we need another angle with 3 letters that also equals 40 degrees. Okay, well, we know, because these aren't square angles, that none of this is 90 degrees, but we do know that we can figure out what this angle is, because the interior of this whole triangle right here equals 180, and this whole triangle equals 180. So 60 plus 40 equals 100. So whatever is less than that, so 180 minus 100 leaves us 80 degrees. So this one up here is 80 degrees. All right, if this is 80 degrees up here, so is this one, which means that this opposite angle right here is our 40-degree angle. And you'll notice that they're going to answer A, DB. In other words, let me draw it in red so you can see it. If this is our 40-degree angle, right, we're going to start with A, go to D, and go to B so that we can get that angle. Or we could also name it BDA, either one. So we'll just start with ADB, and that would be our answer. Okay, so maybe a little bit tricky there, but that does measure 40 degrees, and that is your lesson. If you have any questions, let me know.